All right, we are recording now. So thank you everybody for coming. This is the Nephew SIG Network Architecture meeting. Let me share the agenda. Okay. All right, so thank you. I'll just get the meeting open. So the TSC met last week, and so there's a few updates from that. One is that we have, for this SIG, a vice chair. So I wanted to welcome Kaushik. You may not have seen him here before, but he's been involved internally and is excited to get started. Kaushik, you want to introduce yourself?
Hey, and thanks, John. Hey, everyone. Good to. I did meet some of you at the Nephew Dev Summit, but for those of you who haven't seen much of me with Nephew, I've been kind of like John said, working behind the scenes, hoping to work much more closely with this group now, moving forward in my vice chair capacity. Been at Google for 14 years, worked on many different parts of Google, have been involved with Google's telecom efforts in the last, I would say, 8 or 10 years. And you'll see me hopefully, helping out more on, kind of helping, bring some structure and kind of discipline to this group. Thank you, everyone. And, look forward to working, like I said, more closely with all of you.
Thank you, Kaushik. So the other things coming out of there, SIG platform and SIG automation machinery have been merged into SIG automation, which I will chair. And the last item is that this group needs a chair. So the TSC would like that chair to come from one of the telco members as opposed to from cloud providers or other vendors. And so that is open for nominations. If you go to the wiki, there's a link right there. Basically, you can self-nominate, or obviously with permission from somebody, you can nominate somebody if you want. But you need their bio and everything, so probably it's easier to self-nominate. And I don't recall offhand. I think there's a couple of weeks of open kind of nomination time before the TSC will meet and vote on who should take that role. And then the last item I wanted to bring up is I think we're going to migrate the stuff to, well, we're definitely going to start using Zoom in the next set of meetings, partly because with Meet, somebody in the Nephew org has to admit everybody into the call unless they're use the Google account that's on the invite. It's very inconvenient for this type of open call. And similarly, folks in China can't necessarily access Google Docs and things like that, so we probably are going to need to move to Etherpad and the wiki, which is like a step back in time for some of us, but I guess it's what we have to deal with. I don't know why in other open source communities it hasn't been that way for me, but it's been a long time since I've used those tools. But anyway, that's just my own personal agenda there. So anyway, we'll talk about that more in SIG release, which is right after this call. And that's really all the announcements I have. Tal, I guess you have, Prakash, you've got a hand.
Yeah, thank you. Can you hear me?
Yes.
Okay, so unfortunately, I did not know the link, and it said that this link was valid only from 25th or something. So I went ahead and created one link and put the agenda in the network architecture group under the wiki. I was not aware of this. Sorry for that. Apologize. But then Satish Kumar from Spirent joined, and he said, "Hey, there is a link here. Why don't you join there and see?" if this is the right place. And I said, okay,
I'm
I will
also
jump.
here right now.
Yeah,
Thanks.
Satish. So sorry for that. And we had put some agenda there, which maybe I don't know whether it's right or wrong. You can correct us on that.
I mean, if you're welcome to add it to the agenda here, and if we have time, we can get to it. And I'm happy to take my thing and just briefly discuss it. And we could, because I plan to really do the demo on Wednesday, because it's not quite ready yet. So
Mhm.
if there's other things you want to add, if you go into the Google Doc there, you can just add to the agenda.
Okay.
And time.
Where is the I'll put it in the chat window what I put there, and maybe you can choose what you want to do out of this, because I'm not sure what was this was what I was thinking about, and if there is anything relevant you can pick up. We were more looking at the use case framework and formats discussion and impact from other projects on the ONAP, ORAN, SCP, TIP, OAI, Magma, etc. How Nephew will handle that uh, if
Did you have
we write a use case or something.
right? Okay. Well, so did you have specific questions on these things? Because I don't think anybody's prepared to talk about that today, unless you have
No,
some.
no. Specific means the only thing is if you already have some format for the use case that we can
I
use,
see.
that would be helpful. Other things are only for discussion. Like I started writing the session management function SMF as the use case, and when I started that, then I got inputs from Juniper, input from F5 saying that, hey, you need to include ORAN, you need to include workgroup 6 of it, and so on and so forth. So I got
That's way
so
too
many
big.
requests.
Let's push this off to later, because we have an agenda that we already have. So
Okay,
we'll
thank you.
continue this
But
discussion.
I just given you the inputs what I had got. Okay,
Yeah, no, I
thank you.
appreciate that. That's fine. We'll add that on. We'll talk about that a little bit later, and like anyway, we'll talk about it a little bit later.
Okay.
Okay, your hand went down. I'd like to turn it over to Tal. He's on. Oh, and
Oh.
you.
Sorry. Just for my information, for future meetings, where should I go to look for documentation and agenda after that conversation just now? I'm confused. Sorry.
There'll be an announcement later on where to go.
Oh, okay.
Yeah,
Thanks.
it's in transition. Let's put it that way. It's in transition.
Okay.
Okay, Tal.
Okay, yeah. So I'll be brief and hand it over to my colleague Jose Nunez. But at first, I'll just introduce the connection and what this is about. Last meeting, we started to discuss the use case, the 5G use case, from a very high level, and we mentioned how challenging it is to do something in open source because things are pretty scattered and there are various projects. And I mentioned that, well, my colleague Jose has exactly been working on that and managed to create a fairly complete solution. So he did some work and prepared a presentation today. We try to make it short because we imagine it'd be more interesting to have a conversation rather and a Q&A. So Jose, I will hand it over to you. Thank you.
Thanks, Tal. So may I share my screen, or how do you want to handle?
Yes. I think it'll just let you share your screen. Just go ahead.
Okay. So as Tal said, we're gonna try to keep it short and more oriented on the Q&A. So basically, name is Jose Nunez. I'm a software engineer in Red Hat in the telecom engineering group. I'm gonna try to present quickly an overview, a qualitative analysis of 5G open source software projects, and I'm gonna share with you a little bit how, in our experience, how we can use these projects on top of a Kubernetes infrastructure. So let's try to, yep, that works. That, did you see the new slide? Yeah. Okay, so basically, usually to build a 5G network, you need a radio segment and a core network segment. In 5G terminology, this is called the next generation core. In 4G, it was called the EPC. As for the radio access network segment, it's comprised of base station, which in 3GPP terminology and 5Gs are called next generation node Bs, and these are used to connect user devices, user equipment to the 5G core network. The core network handles control operations such as mobility management, session management functions, as you were guys discussing before, and authentication of user equipment, amongst other functions. So we will try to provide this analysis of current status of 5G open source projects, and also we'll try to give some more hands-on hints and considerations and design considerations when trying to bring these projects on Kubernetes. So first consideration as for the radio segment is, well, a radio segment has usually an over-the-air interface to connect phones with node Bs, evolved node Bs in 4G and next generation node Bs in 5G terminology. So the first question one should think about is whether you want to emulate this over-the-air interface or you want to have a real over-the-air interface. If you want to have a real over-the-air interface, you need additional hardware, which is not per de facto on a Kubernetes cluster. These are this hardware is are based on, it's called software-defined radios, which basically allows you to program a physical layer of cellular or Wi-Fi stacks using software by means of this hardware. Typically, there are they offer an RF front end to connect another USRP or a real mobile phone. And on the other side, they offer a USB device interface or an Ethernet SFP-like connection for the Kubernetes infra to detect them as devices. The UE can be a real phone, or it can also be, with the proper software, a software-defined radio. Note that if you want to build your own cellular network, you also need to be able to program subscriber info with this information, such as the mobile network code, mobile country code, IMSI, etc. You need to be able to get programmable SIM cards. Here in the picture, there's a provider of cards that allows you with some open source software to program the card. So, for instance, if you need to change the email or the key or whatever parameter related to the authentication of the UE with the 5G core, you can do it. If you also want to change and hack the mobile network code of the mobile country code of your PLMN of a subscriber, you can also do it with this kind of hardware and software. And yeah, this acts for the phone as a real SIM card, and it will allow you to register to your own 4G or 5G core network. If, on the other hand, you opt for the other choice, you need to emulate the over-the-air radio, and for that there is open source software that allows you to do this kind of stuff. If you emulate this virtual over-the-air radio, all the components of your end-to-end cellular network will be hosted on top of Kubernetes. This is very useful when you want to, for instance, test your 5G core, or you want to do some demo and you don't care a lot about the over-the-air interface, which I would say that in your case may be the case. We can discuss about that later. But yeah, this is like the first consideration when bringing run open source software to the Kubernetes space. So yeah, we were mentioning before that we were gonna discuss about open source radio projects. So basically, I divided them between those projects that really have an over-the-air interface, and those projects that emulate the over-the-air interface. I have selected these two projects for the 5G radio part, and one is the Open Air interface, which is driven by the Open Air Interface Software Alliance, which is a French non-profit organization that makes a case for building an available suite of open source components for 4G and 5G networks. They provide GNOT-Bs, eNOT-Bs. They are working on making it as 3GPP compliant as possible. Currently, I think they are on some features on 3GPP release 15. They are starting to get some other features on 3GPP release 16. They use software-defined radios for the air interface, and regarding the support of ORAN, or having an open RAN. Yeah, question there.
Hi. Yeah, the question was primarily on how does this tax help in validating vendor workloads, because these, I understand, are mostly for quick prototyping and basically more for academic use and so on. Because if you take typical ORAN deployments where you have open front hall and with CUDUs and vendors coming with a number of requirements on the CAS, PAS, and all that.
Yeah, so these projects are usually for providing fast prototyping and demoing on open source cellular networks. I would not. I don't think they are at the stage of being able to validate workloads from vendors, in the sense that they usually provide functionality, but they do not provide the performance or stress testing that your project may need, right? So
yeah, that is my understanding too. Yes.
Yeah. If your use case is validating a workload vendor, you may need to go with some commercial emulation equipment for that.
Yeah. Particularly if you have front hall implementations and so on. So.
Yeah. Yes. So from what I have seen in terms of front hall, I know that the guys of the OpenAI interface are trying to are in the middle of providing the first integration of their DU stack with some RRU vendors such as Venetel. But I'm not sure what level of maturity are they in at this stage.
Thank you.
Yeah. So on the other side, if we go for emulating the over-the-air interface, two additional projects come to mind here, depending on whether you want to emulate the whole run stack or just partially emulate those parts of the stack that have nothing to do or nothing to deal with the PHY, the MAC, and the PTC up to the PTCP layer. So Core Scope emulates the whole stack over a virtual radio. It's a project based on SIG software radio systems, and emulates using zero MQ networking libraries, the protocols that are up to the PTCP layer on the run stack. The UE run simulator opts for another approach, which is simulating only from the UE control plane and up down to the RRC, which basically means that the physical layer, the MAC layer, the radio link control layer, and PTCP are emulated over UDP in this case. So that's the main difference between both approaches here. Go through the emulation with a full stack or a partial stack. The UE run sim, which is driven by the community and contributes with only a 5G stack, 5G standalone stack, implements the 3GPP layer, everything from the application layer down to the RRC. The rest of the protocols are emulated over UDP, which means that they are not implemented basically. But depending on what your use case is, you may wanna take a look at this. If you don't care about the physical layer parameters and you want to emulate whether 100 subscribers can connect to the 5G core, maybe UE run sim can do this job. So what can we do at the 5G core network segment? So here, from what I have seen in terms of open source, the community is like more cloud native friendly than those projects that have to deal with the radio access network. Usually the projects come in the form of providing a network function of the core. Usually there are a lot of open source projects that offer the user plane function, which is like the golden network function in terms of implementation and variety of choices to select in the open source world, or they offer a full-fledged 5G core. And in terms of 3GPP futures, usually these projects focus a lot on interoperability with other elements in the 3GPP network. So interfaces like S1, N2, and N3 may very well be compliant with 3GPP. What it's more difficult to assert here is what interfaces, what is the level of maturity of these 3GPP interfaces on the internal ones. For those interfaces that do not have to talk with external entities. For instance, you may want to have full 3GPP compliance to connect a 5G core to another 5G core for roaming purposes, but maybe the protocol that's internally used to authenticate with the 5G core of the database is not 3GPP compliant. It's not using, for instance, the diameter protocol, or it's not using what the 3GPP recommends. But they tend to be quite compliant of the external interface in terms of external interfaces. So that's a little bit a table of the different open source projects that we have found in the open source literature. And yeah, it's I would say that they are more cloud native friendly than those projects that have to deal with RAN. For instance, in terms of installation and deployment, all of them provide Helm charts, either in the same open source project or some forked project of the official repositories. And yeah, what I would say here, in addition to licensing and it's that the containerized strategy, it's based on network function entities. So basically, they have a pod per 3GPP network function. Usually, you deploy your 5G core, and you have a 3GPP network function, which is a pod, which is the SMF that can scale up and down. That we have the AMF. You have a network function for the UDF. If you have 4G and 5G combined, you will have more 3GPP network functions. From all these strategies, I would say that there is one proposal which does not totally follow that approach, which is Magma, which tries to go a little bit more fine-grained in terms of the coupling pods from 3GPP network functions. For instance, they provide a pod which is in charge of closing all the SCTP connections. In 4G, if you have a 4G core, 4G technology, and you want to connect your LTE antenna on top of this SCTP transport protocol, which is on this SCTPD pod, you will transport the S1C interface. In 5G, you will have an N2 interface, which carries a different protocol, different messages from those on 5G. So, but still uses SCTP as transport protocol. So what Magma does is to scale and reuse this SCTP daemon on a pod, and just change the pods that we will consume this SCTP protocol. They don't have to replicate the SCTP instance for per technology, let's say. And yes.
Yeah, Jose, it's Wim. I was in the chat asking whether any of these have a netconf interface. For example, when we want to use them with Nepio, we need to give them some provisioning parameters and stuff like that. Do any of these have netconf, or what is the way to interact with them to give them some configurations?
I would say that in the case of Magma, they have, in addition to what a mobile network core is, they provide additional stuff for configuration, orchestration, and monitoring, and they use this kind of protocol for configuring the different elements of the 4G and 5G core. In the case of Magma, they call the 4G and 5G core the Magma Access Gateway, and there is an orchestrator on top that attempts to provision the configuration and provide continuous monitoring on the mobile network.
And what does that protocol? does the orchestration use as a protocol to interact? Is it gRPC or is it?
It's gRPC, but I would say that they also use other protocols.
Okay.
For that, yeah.
Thanks.
Yeah, thanks. So,
Hi, if I may jump in and extend the question.
Yeah.
Is that okay? So since most of these use REST, can you HTTP, which I assume is REST, can you use RESTconf instead of netconf?
it depends on the implementation.
Yeah, but I mean, if
yeah.
your device can speak net/RESTconf, you can probably switch over to RESTconf and talk that way via HTTP to the other components.
Using the REST API for configuring the device.
Yeah. If that's, I don't know who, I forgot who was asking the question.
That could be.
Okay, thanks.
Well, I'll just add that maybe it's a certain advantage for us to have actually a multiplicity of protocols, because we want to address all, if it's netconf, RESTconf, or GNMI, which is kind of the new approach of doing the same over gRPC. So probably good if we have a mix. From my experience, adding a layer, translating one for the other never works.
Yeah,
because,
that's more complication.
Yeah, netconf does not equal netconf is what I often say, because it's so non-standard. Anyway, but we all have a lot of bad experience with that, I'm sure.
It's true with any of them.
Yeah. So just follow-up question. GNMI seem to be the favorite prefer way to go, move forward? Yes, no?
Yes, I think we see, if we look at architecture, I think one of the things that I believe we should do at some point is to make an inventory of which ones we have to support here, because I believe, as we said, it's not going to be, if you look to the Nephew slide today, it's only, it spells out netconf, but I think in reality, there will be probably different kinds. And it would be good to build an inventory out of them just to see what we are aiming for. And of course, based on the use cases and releases, we probably have to limit that potentially. But I think it's good to build an inventory of what we need to, what we are aiming for.
I agree. I agree. Thank you.
Yeah. So now let's try to see with an example how interconnecting all the building blocks for a 5G core and the radios, how all the pieces glued together on top of a Kubernetes cluster, right? First, you see this picture on the left side. There are components that are outside of the cluster. Other components are inside the cluster on top of Kubernetes infra. So that comes back to the question of whether we want to emulate the over-the-air interface on Kubernetes or not. If we don't want to emulate this interface, and we need this kind of hardware with the UEs able to be programmed with some special SIMs. If this is not the case, the emulator will use UEs and GNOTBs in software on the Kubernetes infrastructure. In this case, I have some experience with this project called UE Run SIM, and basically this is a little bit how the pieces and the networks connect together. So there is support with embeds the UE software stack and exposes a network interface that is used to connect to the GNOTB pod. The GNOTB pod has additional network interfaces to connect to the 5G core. For that, you will need pieces such as Multus to extend the number of interfaces per pod. In this case, we have defined for the G0B that it's emulated 3 networks, one to connect to the UE for the emulation part, and 2 additional networks to connect the N2 and N3 interfaces to the 5G core, which in this case I'm using Open5DS, which in addition to these 2 network interfaces has an additional network interface for the N6 interface, which is used to connect what is the UPF to the internet. Basically, there is a disencapsulation of all the GTP tunnels and all the payloads coming from the UEs from the uplink and downlink go to the internet. So here for the interfaces, in addition to Multus, you may need, depending on the project or on your needs, you may need additional plugins. You may need to use SRIOV. You may need to use MacVLAN. You may need to use different. It depends a little bit on your needs and what the project requires. I have some experience connecting networks with MacVLAN plugin, with SRIOV, and yeah. Also important here, if you need to connect a G0B stack using an over-the-air interface through a USRP, through a software-defined radio, there are 2 choices here. You may need to connect through USB or through an additional network interface. So somehow you need to tell to your Kubernetes cluster that how to detect this software-defined radio. So it may be a USB device, or it may be an IP on an SFP on an external box. Yes.
So in sort of the scope of Nefio, where we're talking about trying to look at distributing these components across a fleet of clusters, you're showing in your prototyping, or what the work you did here, you've got your core and your G0Bs and everything on one cluster. Did you do any, I imagine we may want to spread not just the core, but pieces of the core across multiple clusters. We may want to spread, obviously you'd have many clusters with these G0Bs. We'd have maybe UPFs in some places paired with certain functions or not. There may be multiple tiers of clusters. And I imagine we're going to run into questions about how do we expose these interfaces, these Multus interfaces external to the cluster? Is it through external IP? Is it through, do we put some kind of load balancer in there? Have you experimented with any of those things, or have any thoughts in that area?
Yeah, so what I had some experience, for instance, for the case of the 5G core, I worked on decoupling what is the control plane from the user plane. So basically, all the functions related to the user plane were on the edge, and on the edge of the network, very close to the antenna, and all those functions such as MME or AMF were on another cluster, which was farther from the antenna. No latency sensitive requirements in this sense. So yeah, so what I did, I used IPsec channels to interconnect the 2 clusters, and I still used same CNI to interconnect the different functions of the 5G core that were decoupled on different clusters. So I still used Multus for having multiple network interfaces, and I still use same addressing, but I had an additional pod on my cluster that take as input all the traffic that they wanted to send to the other cluster, and encapsulate it on an IPsec tunnel and send it to the other cluster. So I didn't use load balancers in this case.
Okay, yeah. That's a great point, Tal. Sorry, I'll let the other hands just I'll respond. Like, yeah, we didn't transport, like all that was kind of like out of scope because it's hard and we just waved hands. So yeah, I'm just that's a good point. Anyway, what's our queue of hands? Let's see. First we have Anne.
Hi, just a follow on John's question about in scope, out scope. But if it is in scope, or whether or not it's in scope, I'm curious if you have multiple, or are you talking to a single core, or multiple, or are you talking to multiple core? And if in that scenario, do you see any traffic performance by any chance? I mean, I know it's prototyping, but I'm curious.
Yeah, it was more functional testing, prototyping, as you said. I only had one core with network functions decoupled across different clusters. In this case, functions related to the user plane on one cluster, functions related to the control plane in another cluster.
Mhm.
And I had all the radio stuff. I didn't have any decouple, or it was everything on an all-in-one pod. So, and I have USRPs and a real phone, but I didn't have. I didn't go to the stage of testing things like roaming or
Okay.
yeah.
I guess the question then becomes: would that what you just described be in scope or out of scope for Nevio? I'm asking collectively, not just putting.
Yeah,
you on
no,
this.
no, a good question. It's almost a TSC question, and Ravi has a hand, so we'll get to him, I guess, in a second. But like we talked about in the face-to-face, that in our initial discussions, like transport, for example, is out of scope. But that's not so much that it's out of scope of Nephew as it is; it's out of scope of what we were prepared to work on initially, unless the community as a whole wanted to pick it up. So I think that is definitely an open topic. Is exactly what the scope boundaries are, and probably this group as a collective could inform a lot of that. Ravi?
I'm not pushing for a certain boundary. I'm just trying to understand. That's all. Thanks.
Yeah. So my question was primarily on particularly with Red Hat using this internally. I mean, kind of putting up this setup. Is it because of an operator ask? Because generally, as was mentioned, like in the previous question, also, like most of it is very rigorously needs to adhere to 3GPP kind of IoT specs or conformance specs for testing out anything in the RAN, right? So I'm just trying to see how this overall fits within the high level use case discussions that 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 we want to kind of pursue in this group.
Okay. Sorry, I lost my queue. Who is next in the queue?
Sorry, did you hear my question? I'm sorry if I.
I'm sorry. What was the question? I know. I guess I missed it. I don't know if I'm the right one to answer, but I guess I missed it.
Okay. No, the question was like, anything in the RAN has to adhere to either 3GPP's, IoT or conformance spec requirements. I mean, if you want to put some kind of test bed to validate, end-to-end scenarios, there are a number of RF metrics that needs to be measured at the UE end, probably at the base station end, from a performance perspective, end-to-end service perspective, and all that. So, is this test bed or I am at least aware of Open Front Hall, so I know the IoT conformance specs there. So, is this test bed conforming to any of those requirements? Which would we say that okay, if you have this test bed, we could go to an operator and say that we are validating XYZ. So I'm just trying to understand the motivation of of basically bringing this to the table,
Okay.
and how does this fit into the overall use case discussion that is the core of this SIG group.
So I can answer that second part. I think from my perspective, the reason this is super interesting for this group is that we need, so Nephew is about management and about provisioning, and then day two, management of those network functions. So it's deployment of them, configuration of them, and the infrastructure. So we need, as an open source community, we're not going to validate those management functions using vendor functions, those management operations using vendor proprietary commercial network functions. So this isn't so much we want to create, to me, consuming these open source projects isn't so much around an operator is going to run that internally, because they're probably not. It's not around validating whether it performs properly. It's not about validating whether everything works. It's about validating the Nephew management operations. It's around validating that we can provision it and install it in an architecture that looks something like what an operator might use with commercial network functions, and that we can configure the pieces to talk to each other. We can configure the underlying Kubernetes. We can configure the underlying infrastructure underneath that. So it's more of a set of prototyping tools for our CI, CD, and scenario development than it is a goal to build an operational platform using these particular tools. So that's my opinion. I'll just yield the floor to anyone else. I think
no, that's a good motivation. But what I'm saying is that because these are like open source projects and are mostly happening with funding from companies, or it's more in academic realm, they might not consider all the requirements of an operator. So even if you were to do this, there'll be significant gaps in terms of making, trying to get all the requirements that's required from a cluster perspective, cloud perspective, functional 3GPP interface, interoperability perspective, and all that. So I think it's good to go a little bit deep and understand those 3GPP alignments specifically, so that we can say that, okay, this seems to be a valid test bed for to validate anything that we want to do from an Nephew perspective.
That's a good point, and I'll just say one more thing since we have a bunch of hands. That is why we have vendors right here, right? We need, this isn't going to exercise the full depth of what the vendors' products need. And so we need the vendors part of the community and helping us figure that out. And of course, the benefit for them is that their functions can work in this environment. And they can help shape the environment, the project. But we also, I tend to, from a software development point of view, right? We need to work in iterative drafts of the eventual product we're going to produce. And so we have a lot of basic machinery to work out. So you'll see later, and we're not going to get to it now, maybe we'll have to have another meeting this week or something, but you'll see in the use case, if you come Wednesday, like I'm not even using a telco workload, and there's still a lot of things that have to be figured out, right? I'm using a very simple application, stateless application, to try to demonstrate some of the machinery, some of the user workflows, how you configure things, how you change application configuration. There's a whole bunch of pieces to work out. So from a sort of software development, software engineering standpoint, I want to work in simple, successive iterations. So we'll have some use case ultimately that we want to support, but we need to have 5 or 6 iterative steps before we get there of increasing complexity towards that use case. So that's kind of my philosophy, and I think that's how this fits in my mind for that. And vendors will come. We can be participating the whole time, but that level of depth might come a little later.
So I'm very sorry to interrupt. I know there are a bunch of people on the queue. I wanted to make comments. We have 5 more minutes. I do hope for Jose just to at least finish the presentation, and hopefully we can continue discussion some other time, if that's okay with everybody. He has a few more slides.
Before you close on that, one thing is we need to eliminate radio in that case. Like you have eliminated transport, just keep to the core if you want to keep to minimum. Thanks.
Probably for our first cut, yeah.
Hey, Satish from the side. So I just wanted to have some of the questions there. One of the point is basically that as I know that Nephew has to concentrate only on the infra and the management part, but not the application part. Let me know if I'm wrong here. And since we are not supposed to take care of the application level, right? Application layer at all. So this radio part or the core part, it doesn't matter for us, right? That whatever the application layer can be there, we have to focus on the application, the management and the infra layer only. If those works and those are very much generic, right? Then we are good to start with, right? Am I missing something here, or
we're dealing with? I mean, the 3 swim lanes we talked about: infra, workload, and workload config. So by workload, I mean network function. So we want to be able to say we've got these 100 clusters. Where should we need to be able to install on each of those 100 clusters the right workloads, the right network functions, and then we have to be able to tell those network functions how to talk to each other. So we're kind of taking it a little bit step by step, but let's let Jose finish his thing, because we just have a few minutes left.
Okay, great. Yeah, but the type of workload will not matter, right? So
I agree, which is why I started with a non-telco one. Yes.
I will go really fast. So yes, so some additional considerations is, well, as you already may know, you will have to deal with when you deploy your open source 5G network or your 5G network, you will have to deal with a lot of entities and a lot of interfaces that adds quite a lot of complexity in terms of configuration regarding the networking side of things. So CNI, get ready to configure multus, get ready to assign carefully do your planning in terms of IP or IPv6 addressing. Assure that you have a procedure to provision certificates. For the case of the 5G core, you need some entity that can some certificates that so that all the different network functions can authenticate to this function called network repository function, which is the ones that exposes the APIs of the other network functions. Or for the case of the 4G core, you will need certificates for diameter protocol that it's no longer in the 5G core. Yeah, and just to close, take into account also that these open source projects are really still trying to get all the functionality they need working, and there's lack of continuous integration, infrastructure, automation, and there is regarding the integration with the Kubernetes or operator world, there are no operators doing reconciliation loops with 5G core network functions, or even less with the radio functions. There are some help charts available for 5G core, but that's it. That only covers installation. They don't cover day-to-day operations, which are quite important.
Right. Awesome.
And,
well, that's why we're here.
That's all.
Okay. That's awesome. I think that was really helpful. And so time, we have a bunch of other things on the agenda, obviously that aren't going to happen. I don't know that I want to wait 2 weeks for the next meeting. So maybe over email, we should discuss whether we want to meet at the same time next week or we want to meet another time this week. But also, one of my agenda item we can talk about on Wednesday at the SIG automation meeting, if anybody wants to attend. And with that, I guess we should close. Any other last comments?
My only comment, I think, John, is we have to focus on the use case at some point, right? I think if otherwise we are going to, I think that's going to be, I don't know how to do it yet, but that's what we should try to achieve somehow. What are we aiming for? I think at some point.
Plus one to what Wim said. In fact, I pasted a comment. I would request telcos in this group to curate the initial set of use cases that they would like to see the architecture, support, and with the lens of how do we. The goal should be to deploy this in production, not just purely, do some artwork here. So the telcos are best positioned to help, drive that prioritization, and I think that gives the group a good scope of working against.
Is there a way to find out who are the telco representative in this call? Like maybe tagging yourself for the next call with company name or something? Because I love to hear from the telcos what they're thinking.
Yeah, well, we want the chair to be from a telco. So let's talk about that next time or over email. But thank you all. Now is on to the SIG release meeting. So thank you and see you soon.
Thank you. Bye.
Bye.
Okay, thank you. Bye.